For this video, I'm going to be solving the legal question called invert binary tree. Um, I I found out about this question from the blind 75 list. That's basically a list, like, let me see. That's basically a list that is made by, various job recruiters and people who've been in the field for a long time, and people like a lot of people. These are like the most like questions, and if you could do all these questions here, you should be able to pass a tech interview. So I'm just trying to grind this, and I'm using something called Neatcode, which allows me to just track. It's easy. It's easy to track if I do it or not. Know what I mean? So today I'm gonna solve this one, and let's get right into it. So first, let's read the question, right? Given the root of a binary tree, invert the tree and return its root. Let's look at an example. The root is 4 here. We have 2, 1, 3 on left side, 7, 6, 9 on right side. So we're supposed to just bring the right side to left side and left side to right side. So just swap sides, and we just return the root. Okay, so let me write some pseudocode real quick. So first thing we should probably do, right, is check if the array is empty. Check if the root is null, right? 'Cause if the root is null, that means we don't have anything to invert. So we just return 0. So, check if root is null, right? Then we'll probably use recursion, so we'll get the left side, get left side, right? Get right side, and then we'll swap the left, then swap left with right, and then we'll swap right with left, right? So let's run an example real quick. We have 4, right? 4 is not null, so we'll go here. We'll get the left side. We'll get 2, 1, 3. Get the right side. We'll get 7, 6, 8, 6, 9, right? Then we'll swap it. So then we'll put 7 here. We'll put right here and left here, and then we just return the the root, which because that's what it says here. Return the root, right? So let's code this out real quick, right? We'll put an if statement. For if root is equal to null, right? Return 0. Return 0 because if the root is null, so the root doesn't even exist, so we can't even check anything. So that's just a base case, just a case, right? And then we get let's try getting the right side now, right? So how we could do this is we could have let's think, right? We could have let's say let left equal what's this called? Invert tree, right? And then we get root dot left, right? And we get let right, and we get invert tree equal root dot right. I introduce a recursion, so it's going to just go through the tree over and over and get this will get the left, this will get the right, and then what we should do next is do root dot left is equal to right, and root dot right is equal to left, right? So what's that doing? That's what's swapping it. That's what's swapping the elements, right? So then what we should do now is we return root, right? Oops. We return root. So this will return the top, and then we'll basically go, which basically has everything, has all the elements, right? So again, so let's just run it. So we have an error now. Let's see what the error is. If root null, invert tree, root dot left equal right, then root dot right equal left. Then we return the root. What's the error here? One second. So it's not valid for expected return type of. Hmm. Maybe I don't know. Let's try this. I don't think I should change anything though. Yeah, that was just a random guess. Oh, you know when I turn zero, we return null. Okay, now let's try. Okay, see? So it's not zero, it's null because it can't be zero because we're not asking like for a number. We're asking just for the root, and the root is null, so we return null. But so let me go over it again, just in case. First, we check if the root is null. If it is, we return null. If it's not, we keep going. So we get the left side of the tree, at the right side of the tree. We set left side to right, the right side to left, and then we return the root. And if we submit, it should work now. And boom. So yeah, that's how we solve this question.